Welcome to Stopping Power Meters, the video, presented by Top Secret Consumertronics. This educational video will teach you many of the basics associated with kilowatt-hour electric energy meters. This video will also show you a few methods some people are using to slow or stop power meters. The methods described herein are for educational purposes only. Consumertronics does not recommend the illegal use of any method described herein. Note: any broadcast or reproduction of this copyrighted video, in part or in whole, without prior written consent by Consumertronics is strictly forbidden and punishable by federal law. Report all copyright infringers for rewards. Stopping Power Meters, the video, copyright 1998, Consumertronics, all rights reserved. Most people agree that the crime of meter tampering applies to physically disassembling, damaging, or bypassing a utility meter with the intent of causing it to under-register loads. Forcing a utility kilowatt-hour meter to under-register is usually considered to be illegal. While we are not attorneys and can't provide legal advice, we do know that when it comes to load-side methods to stop or slow down utility meters, there are two main schools of thought. 1. The utility argument. Any method used to stop or slow down a utility meter while using the same power is considered to be theft of service or trespassing, even if the meter is located on your own property and you do so from within your home or business and without physically touching the meter. 2. The common sense legal argument. Once the energy passes through the meter, it is the property of the party who pays for it. He can use it in any safe and legal way he wishes. If the meter does not properly register any safe and legal load he uses, that's the fault of the utility. Just as it would be if, as what commonly occurs, the meter over-registers loads and the utility gouges consumers from these overcharges. Since the utility owns and controls their meters, they are 100% responsible for it to accurately measure and record all legal and safe loads. Now, to Stopping Power Meters, the video.
The kilowatt-hour meter, one of mankind's most despised, perhaps most feared technological inventions. Perhaps it's the sinister, unending turning of the rotational disc, like the proverbial screw, always playing its little joke inside your head. Every time you turn on a light bulb, the TV, or an appliance, you know that the utility's meter is watching your every move, always turning, always calculating, always recording, and always intruding into your peace of mind. The kilowatt-hour meter, like an evil gremlin lurking behind your home or business, sees all and knows all. Or does it? Can it be outsmarted? Can it be beaten? As with every technological invention, even the almighty energy meter has its weaknesses. Never before had so much been known about these mysterious devices until a company by the name of Consumertronics decided to crack them open and find out what made them tick. Soon afterwards, John Williams, CEO of Consumertronics, was interviewed on CBS 60 Minutes by Mike Wallace. Almost overnight, Stopping Power Meters, the manual, became an undocumented bestseller. And since that fateful CBS interview, tens of thousands of savvy people have learned about the secrets of the almighty kilowatt-hour meter and its errors and vulnerabilities from this popular manual. Our Stopping Power Meters customers are wise. They're wise because they know that the energy gremlin is costing them thousands of dollars every year. Electric rates are increasing much faster than most people's incomes. Simply as a matter of economic survival, you must understand what the gremlin is doing and how it works. Consumertronics not only offers Stopping Power Meters the manual, but also the Stopping Power Meters educational module, which this video will demonstrate for you. Both the Stopping Power Meters manual and educational module are available only through Consumertronics. If you are interested in ordering these exciting products, call Consumertronics at 505-237-2073 or order our new catalog by sending $3 to Consumertronics, Post Office Box 23097, Albuquerque, New Mexico 87192. Now, let's take a step into the labs at Top Secret Consumertronics and learn more about these fascinating devices.
The meter I'm holding is a version of the meter found in most of today's homes and businesses. The technology hasn't changed much over the decades. The outside of the meter, you can see it has a glass face, and that glass face is secured to the meter with wing nuts. In most meters, kilowatt-hour meters, the glass face is secured using a metal ring around it. And to prevent meter tamperers from getting into the meter, they use a security seal. These are the types of security seals that are used on electric meters today. Incidentally, we sell these types of security seals. Now I'm going to take the glass face off and show you the inside of the meter. This shiny, dimpled aluminum disc is what's called the rotating disc. These odd-shaped metal pieces are the braking magnets. This screw right here adjusts the position of the braking magnets, and by doing that, adjusts the speed of the meter, or the registration of the meter. These are the registration dials right here. This indicates how much energy you are using. I will rotate the meter so you can see how these registration dials connect up with the rotating disc. You can see the rotating disc inside of here, and it is connected through a shaft that has gearing on it to these gear wheels, and these gear wheels are like a clock-like type movement, and the gear wheels that connect the rotating disc shaft with the registration dials that indicate how much energy you are using. Now I'll rotate the meter and show you the side. This screw right here is used to adjust the overload droop adjustment. I'll explain more about that a little bit later. Now, many people who have cheated their meters, what they'll do is they'll drill a small hole into the glass, and then they'll use a piece of straw and they'll jam the rotating disc like this. Or they'll blow in some iron, fine iron dust, and it will collect underneath the braking magnets, and by doing so also slow down or stop the rotating disc. Now I'll turn the meter around. Normally, kilowatt-hour meters have a plate on it. I've taken the plate off so I can show you the various anatomical parts of the meter. This is the voltage coil. These are the current coils. This is where the power comes in, and this is where the power goes out to the load. Right up here, it's hard to see, but there is what's called a shading plate, and it is basically used to compensate for low load conditions in the meter where there are non-linearities. Right beneath the rotating plate, there's what's called a shunt plate. The shunt plate is used to correct for overload droop. I showed you the screw earlier that was used to adjust the shunt plate. The overload droop shunt plate is required because at loads greater than rated loads, the current coils actually produce some braking of the rotating disc, resulting in substantial under-registration or droop. The shunt plate much reduces this droop in the overload region. Both the current and the voltage coils produce electromagnetic fluxes that are 90 degrees out of phase with each other at unity power factor. Both of them together produce eddy currents in the rotating disc that produce an electromagnetic force that is continuously attracted by one set of coils and repulsed by another in such a way as to cause the rotating disc to rotate, and that the produced force is proportional to the RMS voltage times the RMS current times the power factor. Since physics tells us that a force results in an acceleration, that without the braking magnets, the rotating disc would continue to accelerate up to an uncontrollable high speed until stopped by frictional forces. The braking magnets solve this problem by introducing a counter electromagnetic force that opposes the electromagnetic force generated by the disc's eddy currents, and that is proportional to disc speed. Thus, the voltage and current coils work together with the braking magnets to produce a disc rotating speed that is proportional to the RMS voltage times the RMS current times the power factor. This disc speed translates directly through the clock mechanism, which I showed you earlier, into the registration dial readings, and of course your electric bill is based upon the difference of the dial indications between readings. Another way to look at kilowatt-hour meters is as two-phase induction motors. As two-phase induction motor, the rotating disc would be the rotor. There it is right there. And the common laminated iron form that houses the voltage coil and the current coils would be the stator. In fact, in the industry, they are normally called the rotor and stator, respectively. Our popular kilowatt-hour meters manual describes in much greater detail the theory and operation of kilowatt-hour meters. Now let's take a look at the Consumertronics laboratory demonstration area. Now we're back in the Consumertronics lab with the demonstration unit we built to demonstrate how kilowatt-hour meters work in conjunction with loads and how they're slowed down and stopped. This line coming into the kilowatt-hour meters brings the power up to the kilowatt-hour meters. This is an inline fuse that helps protect the system. It goes into the kilowatt-hour meter in the line side. It comes out on the load side where it comes into a power strip. This power strip is symbolic of the distribution network of power that you may find in your home or business. As you can see, the various loads are connected in. In this case, these loads consist of 4 250-watt bulbs for a total of 1,000 watts. This is equivalent to 10 100-watt bulbs or a small heater unit, perhaps. As you can see, that these plugs and connectors are ordinary plugs and connectors. Now I'll turn the system on to show you that it is getting power. Now I'll turn it back off. Here below you see the Stopping Power Meters educational module. We sell this device for educational purposes only under the policies of our catalog. It is designed to stop and slow down kilowatt-hour meters. As you can see, it's plugged into the power strip using an ordinary connector. Please also note that there are no loads that plug into the Stopping Power Meters educational module. Now we'll take a closer look at the Stopping Power Meters educational module. This is the Stopping Power Meters educational module. As you can see, the circuitry in this device is quite simple and modest. The SPMEM has 2 potentiometers, and these contour the output signal in such a way that it will stop or slow the kilowatt-hour meter. This transformer right here connects into the output of the Stopping Power Meters educational module circuit. It conducts this signal into the AC line on the other side of the transformer. This signal then goes into the power strip, into the meter, where it does its job.